So this is a very important sum in vectors. The equation of lines L1 and L2 have been given to you to show that L1 and L2 are skew lines. So what you do is you solve these L1 and L2, equate the R1 and R2. You will get parametric equations. You will get equation 1, 2 and 3 in lambda and mu. So you solve 2 and 3, you can solve any two equations and show that it doesn't satisfy the third one. Or you can solve 1 and 2 and doesn't satisfy the third one. You can show that. So here I have solved 2 and 3. I got lambda is equal to minus half, mu is equal to minus half. I put the value of lambda is equal to minus half, mu is equal to minus half in equation 1. So if I put this in equation 1, on the left hand side it works out to be 3 over 2. When I put minus half, it works out to be 0. So 3 over 2 is not equal to 0. It doesn't satisfy the equation. Therefore the lines are skewed. Find the acute angle between the lines L1 and L2. The acute angles between two lines is the angle between the direction vectors. So these are my two direction vectors. So direction vector of the first line is minus 1, 1, 2. And the direction vector of the second line is 2, 1, 6. To find the angle between the direction vectors, you use the cos theta formula. Correct? You do cos inverse, you will get your answers 45.5. Find a vector perpendicular to both the lines. That's your C1. So you have to find a third vector which is perpendicular to both the lines. Whenever they ask you to find any vectors perpendicular to two given lines, you find the cross product of the two direction vectors. So the direction vector of the first line is minus 1, 1, 2. The direction vector of the second line is 2, 1, 6. So now what do you do in this case is, you take the cross product. You can use your calculator to find the cross product, and your cross product will come to 4, 10, minus 3. So this is a concept you need to remember. It's your direction vectors. This is the third vector is the cross product. Now this is the most important part. Hence determine equation of a line L3 which is perpendicular to both L1 and L2 and intersects both those lines. So now these are skew lines. So this is very roughly I've drawn L1 and L2 as skew lines. Means then neither intersecting nor they are parallel in 3-dimensional. So now what you need to do is we need to assume a point P on line 1. So we use the parametric equation. So we say x is equal to 1 minus lambda, y is equal to 2 plus lambda, z is equal to 2 plus 2 lambda. And similarly we call a point Q on the line L2 as well using the parametric equations. You get your vector PQ. So this is my point P, this is Q. So get your vector PQ. Now P is any point on line, this is P and this is Q. So P is any point on this line and Q is any point on this line, because depending on the value of the parameter. So I find out vector PQ. Correct? That's your position vector of Q minus position vector of P. So I do that, I get my vector PQ. Now it's very important, this part is very important. This vector PQ should be parallel to the direction vector. So there are lines in space. So you have L2, L1 and you have your direction vector of the third line. Correct? Because it's intersecting both of them. So it will intersect both of them only if your points P and Q are such that it's parallel to this. Okay. So PQ is equal to KD, a scalar where K is some scalar. So PQ, we have your PQ, K and D is the direction vector that we got earlier part. You put this in your GDC, put this three equations in GDC. Once you put in GDC, you'll get your value of three variables, obviously, there are three unknowns. You'll get the value of mu, lambda and K. Now, what we have to do is the question is asking you, hence determine the equation of the line L3. So we know the direction vector of L3. We need to know a point on L3. Now either you can either choose point P or point Q. If I happen to choose point P, I'll take this value of mu and put it in P, in the parametric of P. So this will give me point P. So therefore your equation of L3 is equal to R is equal to this point that's point P, plus some sigma I put in because lambda and V both are used into the direction vector. That's how we do this.